Today's video is about the application of Ohm's law in series and parallel circuits. Our first goal today is to know how to construct simple DC electric circuits. The next is to verify experimentally some basic relations for series and parallel circuits. And lastly, to become familiar with the operation and use of the digital and analog multimeters in the measurement of electric current, voltage, and resistance. But first, let us define some terms which is related to this topic. First, let us define what an electric circuit is. So an electric circuit is a closed conducting loop which allows the flow of charges. Next is the electricity, or the science or study of electric charges which is at rest or in motion. Next is the electric charge, which is the electric interaction which is denoted as C or coulomb. Then the electric current is the electric charge per unit time. EMF, or the electromotive force, is the work per unit charge, where also 1 volt equals 1 joules per coulomb. Lastly is the resistance, which is anything that opposes electric current in a circuit, where 1 ohms equals 1 volts per amps. So an Ohm's law is a law that states that the voltage across each resistor is directly proportional to the current flowing through the resistance. So V equals IR, where V is directly proportional to I, where V is the voltage, which is the electromotive force or potential difference, where I is the current. So an electric current is the rate of flow of electric charge past a point or region. So an electric current is said to exist when there is a net flow of electric charge through a region. R is the resistance, which is a measure of the opposition to current flow in an electric circuit. The voltage can be measured using a voltmeter. The current can be measured using an ammeter, while the resistance can be measured using an ohmmeter. The voltage is expressed in volts. The current is expressed in ohms or ampere. And lastly, the resistance is expressed in ohms. In this experiment, we are going to use a PSU, or a power supply unit, where it conducts AC, or an alternating current, to DC, or direct current voltage. Then we're going to use a multimeter to measure the current, voltage, and resistance of the certain circuit. So now, we're going to construct a DC electric circuits in both series and parallel circuits. Let us define the difference between a series and parallel circuits. So a series circuit is two or more elements connected end to end such as the same current passes through each element. A parallel circuit is two or more elements with each terminal connected to the corresponding terminal of the next device so that the same voltage appears across each element. So in conclusion, in series, the current are the same, while in parallel, the voltage are the same. So first, let us draw a series circuit. So a series circuit is a circuit in which resistors are arranged in a chain so that the current has only one path to take. The current is the same through each resistor. So R1, R2, and R3. Then after you place all the resistors to its respective places, you will connect the red wire, which is the positive terminal, then the blue wire, which is the negative terminal, to the PSU, or the power supply unit, which converts AC voltage to DC voltage. In this series circuit, the total voltage across each resistor is equal to the voltage across the PSU. So the higher the value of the resistor, the higher the voltage is across the PSU. So the voltage across the PSU equals V1 plus V2 plus V3. The current of each resistor is equal to the current of the PSU, where the value of the current across the series circuit would remain constant and equal. So total current equals I1 equals I2 equals I3. Then lastly, the total resistance in a series circuit is the sum of all individual resistances. So RT equals R1 plus R2 plus R3. Next, I am going to show you an illustration on what a parallel circuit looks like. And that's it. So in this parallel circuit, the voltage of each resistor is equal to the voltage across the PSU, where the voltage would remain constant and equal. So V PSU equals V1 equals V2 equals V3. Then the total current of each resistor is equal to the current across the PSU, where the current through the PSU is the sum of the current through each resistor. So IP equals I1 plus I2 plus I3. While the inverse of the total resistance in a parallel circuit is equal to the sum of the inverse of each individual resistances. So 1 over RT equals 1 over R1 plus 1 over R2 plus 1 over R3. So now, I'm going to show you what a digital multimeter and analog multimeter is. So this is the analog multimeter. So this is the scale, which has the values to be read. Then this is the needle or pointer, which points on the reading shown. Then this is the range. This is where you can select in what you're going to measure, whether it is a current, voltage, or resistance. Then this is the range selector. So it is the control where you can select the range to be used. So in this section, which codes the probe socket, where you can connect the positive and negative probes. So this is the digital multimeter. So this is the display. It is where the current, voltage, and resistance reading will be shown digitally. Then next is the selection dial. This is where you can select modes, whether what you are going to test, if it is a voltage, current, or resistance. Then these holes there are the probe sockets. This is where you can connect your positive and negative probes. Finally, we already accomplished the 3 objectives. That's all for this video, and I hope you learned some backgrounds on how this experiment flows, so that you will now be ready for your first experiment. Thank you for watching.